Okay, so last video we had a bit of a chat about solving simultaneous equations using what we called the elimination method. Well, what I'm going to do in this video is I'm going to show you a slightly different method of doing it, which is called the substitution method. Okay, we'll still get the same results, and in some cases it's easier to use this method. Okay, I won't chat about that in this video, okay, because I've had a little bit of a chat about that in class. Okay, but basically, when we're using the substitution method, it requires us to rearrange our equation so we have the form y equals something or x equals something in the equation. Much like what we have here. You'll notice we have y as the subject of the equation. It's y equals all of this and y equals all of that. Okay? So when we talk about substitution method, this is much like what we do with substitution in just basic algebra. Okay? So I'm going to jump straight in and show you how we can find the solution to this system of equations here. Okay, so first things first, label both of our equations. Okay, again, we're really wanting to be communicating our understanding to whoever is reading this, and we're trying to make it as clear as possible. Okay, so what we're going to do, you'll notice that both of these equations here are equal to y. Okay, this expression here and this expression here are both equal to y. And if they're both equal to y, that means that they are equal to each other. Okay, so technically we're going to take this expression here and substitute it, replace all of this and substitute it here for this y. Okay, alright, so wherever we see a y in this second equation, we're going to replace it with minus 3x plus 2. Okay, so we're going to say sub equation 1 into 2. Okay, so let's go down and do this. Wherever we see a y, we now replace it with the whole expression, not just one, like the negative 3x or the 2, we replace it with the whole expression. So we have minus 3x plus 2 is equal to 7x minus 8. And we can do that because these two things are equal to each other because they're both equal to y. Now we have, just like in elimination, we've gotten rid of one of the variables in this equation. It's only in terms of x. And we can solve this just like a normal equation with variables on both sides. We want to move all of the variables to one side and all of the numbers to the other so we can start to solve this. To do that, okay, we want to move the variables to the side which has the larger coefficient, okay, out the front of the variable. You notice 7 is larger than negative 3, so we're going to get rid of negative 3. We're going to add 3x to both sides. That will cancel, leaving us with 2 is equal to 7x plus 3x is 10x minus 8. Now we want to get x by itself, so we're going to add 8 to both sides. Okay, leaving the 10 till last. We now have 10 is equal to 10x. Okay, I'm going to move this up so you can see what we're doing. Okay, dividing both sides by 10 leaves us with x is equal to 1. Okay, but that's only half the job done. We still need to find y. So we can sub it into any equation that we like. I'm going to pick 2, okay? It doesn't matter which one you want to do, okay? All you have to say is sub x equals 1 into equation 2. Again, we're being really clear with what we're doing here, okay? So sub x equals 1 into 2, okay? That means wherever we see an x up here in this equation, we now replace it with a 1, okay? So we have y is equal to 7 times 1, okay? I'll just move this up so you can see, minus 8. And 7 times 1 is to 7, minus 8 is minus 1. So y is equal to minus 1. So therefore our solution is x is equal to 1 and y is equal to minus 1, just as what we found out just there. Okay, remember we're trying to find two solutions to the two variables, okay, because we have both x and y that are unknown. And we can only do that because we have these two equations. Okay, so let's move on and have a little bit of a go of a harder example. Okay, so moving on to this second example, we're going to do a very, very, very similar thing. Okay, so first thing, okay, we're going to attempt to use the substitution method after we label our equations. Remember, we're wanting to use the substitution method whenever we have y equal to something, okay, or x equal to something. That just allows us to work by substituting in this expression into the other equation. You'll notice here we have y is equal to x plus 3. So what we're going to do to use the substitution method is we're going to substitute this whole expression, this x plus 3, into the first equation, okay, wherever we see a y. Not just the x, not just the 3, but the whole thing wherever we see a y. Okay? So let's write this out. So sub y equals x plus 3 into, and we're taking equation 2 and subbing it into 1. Okay, so what we're going to do, okay, is now wherever we see a y in this first equation, we just replace it. So we have 2x minus 3 outside of. So now we're replacing the y with the x plus 3. And it's really important that you put brackets in here. Okay, because otherwise when you multiply this out, if you don't have brackets, it's only 3 multiplying the x, not negative 3 multiplying both terms. Okay, is equal to negative 8. So there's the idea of substitution method right there. We have just substituted it in. Okay, so I'm just going to move this up so you can see where we're going. Okay, let's expand this bracket out. We have 2x minus 3 times x. Okay, and then minus 3 times positive 3. Minus 9 is equal to minus 8. Do a little bit more tidying up. Okay, 2x minus 3x is minus x. Minus 9 is equal to minus 8. Now we want to get the x by itself. Okay, we want to plus 9 to both sides, doing the opposite. Okay, so minus x is now equal to minus 8 plus 9 is 1. Okay, and multiplying both sides by a negative. Okay, by negative 1. Okay, and by negative 1. Okay, creates this to being x is equal to negative 1. So what we're going to do now is we're going to sub x equals negative 1 back into one of our equations. What we're going to do is we're going to try and make our work a little bit less, okay? Rather than subbing it into this equation where we have to do a lot of working out, if we sub it into the second equation with y already equal to something, we just have to evaluate the right-hand side, and we're already at our answer. So wherever we see an x in the second equation, okay, we're just going to replace it with a negative 1. So y is equal to, let's bring this up so you see what we're doing, is equal to minus 1, okay, just replacing that x, alright, plus 3. Okay, and negative 1 plus 3 means y is equal to 2. So our solution to this question is x equals minus 1 and y equals 2. Again, like I said in the last video, this just represents the point of intersection of two lines, okay? That's all we're talking about when we're doing these sorts of solutions. Alright, so let's go on to our final example and just make it slightly harder where we need a little bit of rearranging. Okay, so here's what we're going to do to use the substitution method on this. You'll notice in either equation we don't have x is equal to something or y is equal to something, so we're going to have a little bit of a play around with this so we can use the substitution method. Okay, notice that we could use the elimination method on this if we wanted to after modifying one of the equations, okay, but we're not going to at the moment. So what I'm going to do, okay, is I'm going to rearrange this first equation here to have it x equal to something. To do that, I need to add y to both sides. Okay, so if I have x minus y is equal to 1, if I add y to both sides, okay, add y to both sides, that will cancel, and I have x is equal to y plus 1. Okay, so this is my new equation here, x is equal to y plus 1, and we're going to call this equation 3. So now we have x equals something, we can use the substitution method. Okay, so I'm going to sub x equals y plus 1 using our third equation into the second equation, which is what we want to do. Okay, and this is wherever we see an x now, we're going to replace it with y plus 1. Okay, so this is what we end up with. So 3, wherever we see an x, we replace it with a y plus 1 plus 2y is equal to 8. So now we're going to do a little bit of tidying up here, okay? Expand this bracket, we have 3y plus 3 plus 2y is equal to 8. Now we want to collect our like terms. I'm just going to go up a little bit so you can see what we're doing. Collecting our like terms, we now have 5y plus 3 is equal to 8. We're going to subtract 3 off of both sides to get y by itself, right? We're working towards getting y by itself. So that gives us 5y is equal to 8 minus 3, after they cancel, sorry. 8 minus 3 is 5. Okay, and now we need to divide both sides by 5 to give us y is equal to 1. Okay, you can see that down there. Now, what we're going to do is we're going to substitute this y equals 1 back up into our first equation. Okay, again, trying to avoid substituting into our third equation in case we've made a mistake. Okay, you could in this case. We're pretty confident that we haven't made a mistake here. Alright, but just in case, if you were doing a more complex version of this, we'll substitute it into one of the originals. Okay, so that is, if we just remember that, x minus y is equal to 1. Wherever we now see a y, we're going to replace it with a 1 here. Okay, so sub y equals 1 into equation 1. Therefore, x minus 1 is equal to 1. So that's just replacing that y. Sorry guys, I'll move that up so you can see it. That's just replacing that y with a 1. That's all we've done. We've just substituted it back into the equation. Okay? So x minus 1 being equal to 1, alright, we just have to add 1 to both sides. That will cancel, giving us x is equal to 2. So therefore our solution, okay, our solution is x is equal to 2 and y is equal to 1. And that is a solution to our simultaneous equation here. Okay? Now I'm going to do one final example which is a little bit harder, and it sort of explains why we shouldn't really be using the substitution method on a certain type of question, because it just makes our life a little bit more difficult. Okay, so this will be the final example of this video, and this would be an example where I would use the elimination method instead. Okay, it's just a little bit cleaner, it makes a little bit more sense, we don't have to work with as many fractions, overall just an easier time. Okay, so for this example, whenever we're using the substitution method, remember I told you we have to rearrange to have y equals to something. So I'm going to take this first equation. It could also be x equal to something, but we're going to rearrange just to have y is equal to something. Okay, so I'm going to take the first equation and I'm going to do this in red. Okay, so I have 3x plus 2y is equal to 6. What I want to do is I want to move the 3x to the other side, so I'm going to minus 3x from both sides. Okay, so I now have 2y is equal to minus 3x plus 6. Now I'm not quite done yet because I still haven't got y by itself, so I need to divide both sides by 2. Okay, so that now leaves me with y is equal to minus 3x plus 6 all over 2. When we were substituting in our expressions before, we didn't have to worry about something looking like this horrific fraction. Okay, we're trying to make our life a little bit easier. Okay, so this is what we have established, and this would be our equation 3. So we're going to sub this whole thing into equation 2. Okay, so let's just move this up. So we write this out, again communicating what we're doing. So sub y equals minus 3x plus 6 all over 2 into equation 2. And what we're going to do is wherever we see a y in this equation, we're replacing it with this fraction, this horrific thing that we're working with now. And you're starting to see why we would start to use the elimination method, because we don't have to deal with this sort of stuff. Okay, so now we have 5x plus, we're going to do 3, now we have a y. We now replace it with minus 3x, okay, plus 6 all over 2 is equal to 11. Alright? Okay, so here's where the tidying up has to be done. We need to expand this bracket, okay? Now I've taught you when we expand 3 into the fraction, okay, we're only going to be multiplying the 3 along the top. Okay, so we have 5x, alright, plus minus 9, 3 times negative 3x is minus 9x, plus 3 times 6 is 18. All over 2 is now equal to 11. Okay, now we're working with a fraction here, and I don't particularly want to do that. So what we're going to do is we're going to multiply the whole thing, everything by 2. Okay, like we would when we're in the elimination method, to clear that denominator. Okay, so this would mean this would be multiplied by 2, this would be multiplied by 2, and this would be multiplied by 2. Okay, so multiplying 5x by 2, we end up with 10x. By multiplying this middle term here by 2, we're actually cancelling the denominators here. So we end up being just left with minus 9x plus 18 is equal to 2 times 11, which is 22. You can already see how complicated this has become just by using the substitution method rather than using the elimination method. Okay, so now we're going to tidy this up, collect some like terms. 10x minus 9x is just x, plus 18 is equal to 22. So what we need to do now is we need to subtract 18 from both sides. Okay, just like what we normally will, and x is now equal to 4. We're not quite done yet, okay? We still need to find y. We found x, but we need to find y, okay? So to do this, what we need to do is just like what we normally would, okay? I'm going to sub it into one of our original equations. I'm just going to pick equation 1, just because it's easy to work with, it's smaller numbers, okay? And remember, our equation 1 was 3x plus 2y. I'll just write it down here so we can continue going down here. Okay, so I'm going to sub x equals 4 into equation 1. Okay, now that means wherever we see an x, we now replace it with a 4. So 3 times 4, okay, 3x, plus 2y is equal to 6. 3 times 4 is 12, so we have 12 plus 2y is equal to 6. Okay, now let's just continue moving this up. Okay, so you can see what's happening. Alright, now I'm going to minus 12 from both sides, okay, to get the 2y by itself. That will cancel, leaving us with 2y is equal to 6 minus 12 is minus 6. Okay, we're nearly there, okay, after all of that. Alright, divide both sides by 2. Okay, to leave us with y is equal to negative 6 divided by 2 is negative 3. So the solution to these two equations is x is equal to 4 and y equals negative 3. Okay, that is essentially what is happening with this particular example. You will notice how much working out we had to go through to get to the answer and how complex it became. So this would be an example where I would try and use the elimination method to come to an answer rather than having to worry about all of this fraction work. Okay, because we've created a lot of extra work for ourselves. Okay, I hope that helps in your understanding, okay, and I hope that you get some use out of this. Thank you.